you're dealing with algebraic fractions, go back to exactly how you would deal with any other fraction calculation, and then just look to see if you can simplify further on using your algebraic knowledge. So let's say we have something like 4x over 3, and let's say we're going to subtract x over, let's say, 5, okay? If this was an ordinary fraction, we would either make equivalent fractions, or we would use this method, which is to multiply the two denominators to get 15, and then we'd multiply across diagonally to get 5 lots of 4x to make 20x, and 3 lots of x to make 3x. Always double check the sign you've got in the middle there. So this is a subtraction. So you've got 20x minus 3x. That gives us a total of 17x as a numerator over 15. We do exactly the same whether we are adding or subtracting, okay, so we can use that same method. If you are dealing, so let's do it with an addition as well. So let's say we've got 6 over, we'll go the other way around this time. We'll do, oops, let's not go with 3x, it'll be simple. 6 over, let's say 5x, and we're going to add that to 3 over, let's say 7x. Okay, same thing. We'll multiply the two denominators together here to get 35. This will be x squared. Okay, x times x. And then over the diagonal, we've got 6 lots of 7x is 42x. And 5 lots of x times 3 is add 15x. Okay, what we can do at this point, and as I said, we're simplifying our algebra, is, well, let's just add these together at the moment. So we're going to end up with 57x over 35x squared, as I can eliminate an x for an x. So imagine x squared is x times x. We can eliminate one of those x's, leaving me simply with just the x there, okay? So now I can just write that in the simplest possible terms. So 57 and 35 do not have any common factors, so we're just going to leave those as 57 over 35, and then we've still got the x in the denominator there. If I was to add multiplication and division in here, well, we can still do exactly the same sort of principle. Let's say we've got, let's make it a little bit more complicated. We're going to use more complicated expressions. So we're going to have x plus 1, let's say, over 5. Let's say that's times by 5x, let's say, over, let's say, 6. Okay, with multiplying, he's going to multiply across the numerators. So we might want to use a bracket here, okay, and obviously at the bottom, the denominators are multiplied together to get 30. Let's expand our bracket. So we can simplify at that point if you prefer, but we'll expand our bracket. So we get 5 x squared, so I'm multiplying in turn, and then 5 times 1 is just 5x, still over 30. And here we're looking for any common factors. So common factors of 5 and 30, of course, are 5. So we're going to end up with x squared plus x at the top, and then we're going to divide 30 by 5 to get 6. We could, if we wanted to, take this a step further and factorise out the top, so but x is common to both here, so we could rewrite it in this sort of standard If I was to look at a division, we'll go for something similar. So I have x plus 2 over 3 divided by x minus 3 over 4. So remember with divisions, you want to flip the second fraction over, change the sign into a multiplication, and keep the original fraction, the first fraction if you like, as it is. So we're going to essentially be carrying out this calculation. And let's see how that works out. So we've got 4 lots of x plus 2 over 3 lots of x minus 3. And let's expand our brackets. Again, remember, we're just going to be timesing the outer term by the inside terms. In turn, so we're going to have 4x plus 8 over 3x minus 9. Again, look to see if you have got any common factors. In this case, we don't, so we would leave this as it is. So we might be asked to solve equations that are involved in algebraic fractions. So let's go with something like x plus 1, let's say over 4, and maybe that's added to x plus 2 over 3, and maybe that's equal to something like 12 minus x. So it can become quite complicated, but just remember these are essentially linear equations just with fractions involved. So I would expand the left-hand side for now, so I'm just going to do the denominators multiply together, and then of course as before multiply across the diagonals. So I'm going to end up with 3 lots of x plus 1 added to 4 lots of x plus 2. Doesn't look much like a 2, does it? Let's try that one again. X plus 2. And on the bottom we've got 3 times by 4 is 12. And on this side we haven't done anything yet to the right hand side. Let's now expand our brackets. And we can multiply at the same time. We multiply the other side by 12, okay? That's just going to get rid of that denominator. So I'm going to end up with 3x plus 3 plus 4x plus 8 equals, and I'm multiplying the 12 now by this side. So I'm going to get 12 12s are 144 minus 12x. Okay. Oops. Put that back in. Okay. Now I want to simplify wherever possible. So I've got the 3x and the 4x makes 7x. I'm also going to add 12x to that, okay, because by doing so I get all of my x values to one side. So I've got 7x, add an extra 12x, makes 19x. And then I've got the 3 and the 8 to make 11. And I'm going to be subtracting that from 144. Okay, so again, what I'm doing now is separating both sides. So you may need more steps. That's absolutely fine. So that will equal 133 now. So I've taken the 3 and the 8 away from the 144 on the right hand side. If I now want to find out what just x is, I can divide by 19. So essentially I'm dividing by 19 at this point, both sides. So I end up with x on the left, and that will be 7 over on the right. So we know that x is 7.